Good morning, Algebra. Today we are going to be talking about graphing square root functions. This chin strap keeps falling off, so I have to keep adjusting it, but that's okay. We have two more sections left in this chapter, so we're going to do those today and Friday, and then next week we're going to do a review on Tuesday, and you're going to have your test on Thursday. And then the following week, we're probably just going to start. We're going to have 3 weeks left of school after that, and the following week we're going to start doing like week-long we have 4 weeks left of school. We're going to do week-long projects. So I'm going to give you a project on Monday, and we're still going to have our Monday, Wednesday, Friday, or Tuesday, Thursday class meetings, and then we are going to you're going to have them due on Friday. So that's what's going to be happening over the course of the end of the school year. I'm hoping everyone is staying safe. I hope everyone is staying, is doing, everything they should. So let's just get into it. So we're going to talk about graphing square root functions. Graphing square root functions. It's actually a pretty simple thing. We're going to have right here, we're going to go up to this. We're going to have our graph. All right, so let's say y equals, let's pull this up some, y equals square root of x. Again, I would just make it an xy chart, x, y. What I'm going to do, what I want to do, is I want to have my x's be a perfect square, so my y is a perfect square root. We're going to assume everything is positive. We're going to assume everything is that we're not going to do plus minus. It's just going to be positive. So we're going to have 0. Square root of 0 is 0. So that's easy. If x is 1, square root of that is 1. All right. Now it gets a little bit tricky, because we got to look at the perfect squares. X is the one that should be the perfect square. So the next perfect square after 1 is 4. And the square root of that is 2. So 1, 2, 3, 4, 1, 2. There you go. And the last one I'm going to do is 9, 3. 9, 3. Because 9 is a perfect square, and 3 is the square root. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. And so this is nonlinear, and it looks like that. And it's going to continue to look like that. Next one's going to be 16, 4, and then 25, 5. I'm not getting into all that because that's just a lot of stuff to do, and it's going to be a very long graph. But there are other ones that we're going to do as well. So, for example, if I see something that looks like y equals square root of 2x. Well, kind of the same thing. We're going to make the x and y chart. The x and y chart like that. So again, I want to try to find things that are going to be perfect squares for x. Again, we can do 0, 0. That's an easy one. Okay? But if I want my perfect square, see, what we can base it off of is our y's. 1, 2, and 3. 1, 2, and 3. Like that. Okay? We can base it off of the y's. So it's going to be a little bit trickier. So we can kind of do a reverse order of operations, plug in y, and then solve for x by squaring everything. Probably the easiest thing to do. So if we say, and I'm just going to do 1 equals square root of 2x, then 1 equals 2x. That's just squaring everything, and therefore x equals 1/2. So 1/2. So 1/2, 1, like that. And then we can do the other one. 2 equals square root of 2x, square everything, 4 equals 2x, x equals 2. So, in this case, if x is 2, y is 2. 1, 2, 1, 2. And then the last one we're going to do is 3. 3 equals square root of 2x. And then we square everything. 9 equals 2x. Therefore, x equals 9 halves, or 4.5, or 4.5, however you want to say it. 9 halves. So 1, 2, x equals it. 1, 2, 3, 4 and a half. 1, 2, 3. And there is my graph. You can see it looks different than the original. It kind of translates to go a little bit higher. Actually, it dilates to be a little bit higher. So we can have another one where it's going to look like we're going to have the same thing, but we're going to have y equals 2 times the square root of x. Y equals 2 times the square root of x. Okay, this one's a little bit tricky, but we're going to do, again, our x, y chart. And we can say that the, we have 0, 1, 2, 3. We're going to do those again. Try them that way. This might be a little bit trickier, but we're still going to do it. We're going to plug in. So again, if x is 0, y is 0, that's always going to be the same. In this case, y is equal to 1. 1 equals 2 square root of x. And then we say 1/2 equals square root of x. So x equals 1/4. So 1/4, 1/2. I'm going to make this, it's going to get in my way. So that would be 1/4. Sorry, no, that's 1/4. And then y is 1. So let's try it with 2. 2 equals 2 square root of x. Therefore, 1 equals square root of x. X equals 1. Easy enough. So 1, 2. Like that. So plug it in. 1, 2. And the last one I'm going to do is 3 equals 2 times square root of x. Then we can say, okay, did I do that? Oh, that's right. 3/2 equals, yeah, 3/2 equals square root of x, square both sides. That means 9/4 equals x. So 2 1/4. 1, 2 1/4, 3, 1, 2, 3, and so this one is going to look a little bit different. You can see how they're all looking a little bit different. And everything else after that is really just solving. We can have one that looks like do another graph. Y equals square root of x plus 5. This plus 5 is outside of the radical sign. Actually, this is pretty easy. This one is pretty easy. This is the same as this one, except up 5. 1, 2, 3, 4, 5. And it just looks like that one. The other one, we say y, let's go with equals square root of x minus 5. In this case, the minus 5 is inside the radical. If it's inside the radical, we have to do something a little bit different. In this case, up here, when it went up, it was outside and was plus. But this side, it's inside, it's going to do the opposite of what it would think like. And if it's inside the radical, it goes horizontally. So this one goes, we would think horizontally, negative to the left. No, because it's inside, it's going to go opposite to the right. 1, 2, 3, 4, 5. And then it models this one right here. So up that one, 1, 2, right there, and it just looks like that. So we can see this when it comes to making an XY chart. XY. So let's see. For this one, we have to solve. So if y is 0, x is going to have to be 5, because 5 minus 5 equals 0. If y is 1, x is going to have to be 6. 6 minus 5 is 1, square root of 1 is 1. If y is 2, well, that we're going off of is our y's, this has to be, inside of here has to be 4, because the square root of 4 is going to give us our 2. So it's 9 minus 5. 9 minus 5 is going to give us our 4. So we can say, okay, so let's just do this one right here. Let me give you this right here. So we have 2 equals square root of x minus 5. 4 equals x minus 5 because I squared both sides, and therefore x equals 9. And that's how that one works. If you have any questions, please feel free to email me. After this one, we are just going to be doing one more section. That section is going to be trigonometric ratios, which is a little bit annoying, but I like it, so it's going to be kind of fun. We're going to be doing that on Friday. So if you have any questions, please feel free to email me between now and then. All right. See you.